So before we start this example, I just want to express that the central limit theorem deals with data that's not taken one at a time, like in previous chapters, but is taken, for example, 2, 3, 4 at a time. Then those 2, 3, 4 pieces of data are averaged together, and we study how the distribution of the averages look. So let's take a look at this scenario. All right, so we had students roll some dice, and the first time they rolled one dice and they wrote down the frequency of getting each one. So they rolled a 1 55 times. Then they rolled 2 dice. So that means, for example, they rolled 2 dice at the same time, and if they rolled a 3 and a 4, they would add those up, 3 plus 4, get the average, which is 7 divided by 2, 3.5, and they would put a tally here. So 72 times they got 2 dice to average 3.5. Then they did the same with 5 dice. And then they did the same with 10 dice. So if you take a look at this data, you can kind of try and figure out some of the distributions. These all look fairly even, except for 5, which has 40. Then you'll notice as you move along looking at the data, that the data starts to tend to go into the middle, and we've got 0. If you roll 5 dice, 0 times was the average 1. 0 times was the average 6. So if you start to take a look at this data, we've got our mean here, and what you notice is the mean is fairly similar across all of them. The standard deviations actually start to get smaller and smaller, and the same for the variance starts to get smaller and smaller. So let's take a look at some of these histograms and what they look like in histogram form. So this histogram shows rolling one dice. This actually looks quite like a uniform distribution. If we just drew a line across there, it would be a uniform distribution. And this is where the number of times you roll a 1, number of times you rolled a 2, so on and so forth. And if we look at, let's look at the next few. If we look at this graph here, this is the graph. Notice that my notation has changed. This is X bar the average, right? The average of 2 dice rolls now. So this is the average. Look how it's starting to look more like a normal distribution. Right here, this is what the histogram looks like for rolling 5 dice, and this down here is for 10. And what you can see is that the data, as we get more and more data, our samples increase, our data starts to get more concentrated around the center. It looks like a normal distribution. Now, if we go back up here, something I wanted to point out was right here, this section, the theoretical, and we will learn how to calculate the theoretical in this chapter, in the central limit theorem chapter. What I want you to notice is the theoretical means are the same. They don't change. Again, the standard deviations, as the number of samples increases, the standard deviation decreases, and the same for the variance.